Alright, welcome back. Brace yourselves now. We're going to do some heart work looking at the structure of the heart. Okay, so what you see here is a very simplified diagram of the heart. Now, there are many other diagrams out there, but we're going to start by looking at this one. And we're going to build on to this diagram little bits of information as we move along this video, labeling different parts of the heart, so that by the end of the video, you should be quite familiar at least with this basic diagram of the heart. To begin with, we need to know which side of the heart is our left side and which side is the right side. Now, the easy way to do this is to look for the pointed end of the heart. So you can see the pointed end is over here. This is what we call the apex of the heart. The side which includes the apex is the left side. So this is the left side of the heart, and this is the right side of the heart. Okay, so the left side includes the apex and is divided in the center that way. Now you might be wondering, why is this so weird? I mean, this is the right side of the screen, so why is this the left side of the heart? Now imagine if there was a person speaking to you, standing in front of you, speaking to you right now, facing you. Now if you look at that person's heart, that is how it would look like. Okay, so if the person is standing in front of you, looking at you, talking to you, his heart would look like this, right? The left side of his heart would be on your right, and the right side of his heart would be on your left. Okay, so that's how we usually draw our diagrams, as if that there was a person facing you. So this is the left side of the heart, this is the right side of the heart. Again, if you get lost, always look for the pointed part of the heart, called the apex, and that would be the left side. Okay, so we can see here the diagram again, and this is the left side of our heart, and this is the right side of our heart. Now in the middle, there's a structure that separates the left and right side of the heart, and this structure has a name. This is called the median septum. Median meaning the middle, septum meaning something that separates. So the median septum separates the left side of the heart from the right side of the heart. And as we shall see, this is really important because the left side of the heart and the right side of the heart contain different types of blood. So the left side of the heart actually contains oxygenated blood. So you can take a color pencil and you can actually shade the left side red because it contains the oxygenated blood. While the right side of the heart contains deoxygenated blood. So if you want, you can shade it blue. Of course, this is just a representation. We know that deoxygenated blood is not actually blue in color. It's just a darker red. Okay, so in your diagram now, you can see that the right side is the one that contains the deoxygenated blood. The left side, the oxygenated blood. And that's why the median septum is so important. If there was a hole in the heart, right, if there's a hole in the median septum, then the oxygenated blood and deoxygenated blood would mix together, and that would reduce the efficiency of transporting oxygen to the different parts of the body. So here's the question that we just talked about. What happens if the median septum is damaged? Well, deoxygenated blood would mix with oxygenated blood, and that would result in less oxygen being transported to the rest of our body, as we shall see later on. So this mixing of blood is no good. Okay, now that we've sorted out which is the left side of the heart and the right side of the heart, we can start to name the heart chambers. So the heart chamber just means a space. The heart has 4 chambers, 1, 2, 3, and 4. It's like a 4-room HDB flat, 4 rooms, 4 chambers, 1, 2, 3, and 4. So you can start to name them. Chamber 1 over here, this is called the right atrium. And chamber 2 over here is called the left atrium. Okay, so you can see that these 2 chambers at the top are called atrium. Okay, the plural, singular is atrium, plural is atria. Okay, so there are 2 atria at the top. They're the smaller chambers. The atrium, as we shall see, they receive blood into the heart. Right, chambers 3 and 4 are the ventricles. So the right ventricle and then the left ventricle. So these are the larger chambers, and these are the chambers which pump blood out of the heart. Okay, so ventricle, the plural is ventricles. Okay, so sorted out 4 chambers, you need to know what they're called. Okay, so as I've mentioned in the previous slide, the atrium or plural atria, receives blood into the heart. Okay, so this one, the right atrium will receive blood into the heart from this blood vessel, which we will name soon. And this one, the left atrium, will receive blood into the heart as well from this blood vessel, which we will also name soon. And the ventricle, plural ventricles, are the chambers that pump blood out of the heart. So here, the right ventricle would pump blood out into this vessel, which we will name in the next slide. And this, the left ventricle, will pump blood out this way into this vessel here, which we will also name in the next slide. Alright, we are now in a position to name the main blood vessels which surround the heart. Now the names should sound familiar to you because we actually talked about it in the previous video. The main blood vessels that surround the heart, for example, the vena cava, the aorta, the pulmonary vein, and the pulmonary artery. So you already know the names. You just need to now label and map the names onto this diagram. So which blood vessel is which, right? It looks a bit confusing at the start. So take out a pen. I would like you to label and also to draw arrows to show the flow of blood through the heart. Okay, that will be really helpful for you later on. So let's start with the blood vessel over here. This blood vessel is the vena cava. Now if you recall, the vena cava transports deoxygenated blood from the body into the heart. Now more specifically, we can see that the vena cava transports deoxygenated blood into the right atrium. Now from the right atrium, blood moves into the right ventricle. And from the right ventricle, blood is going to be pumped out of the heart into this blood vessel here. Now this blood vessel here is called the pulmonary artery. Okay, so the pulmonary artery, if you recall, it will transport deoxygenated blood out of the heart to the lungs. Okay, so the right ventricle, blood is pumped out of the heart to the lungs. Alright, now we need to turn our attention to the other side of the heart. And I'm going to change my pen color because now, after blood has gone to the lungs, it becomes oxygenated, right? So it picks up oxygen and now it has oxygen. It's oxygenated blood. So oxygenated blood actually returns to the heart through this blood vessel here. And this blood vessel here coming into the left atrium is the pulmonary vein. So if you recall, the pulmonary vein transports oxygenated blood from the lungs into the heart, and more specifically into the left atrium. So now from the left atrium, blood moves into the left ventricle over here, and from the left ventricle, blood will be pumped out of the heart into this blood vessel here. So here, then imagine it's at the back, and it comes around here over this arch-shaped blood vessel. So blood from the left ventricle will be pumped out from this blood vessel, and this blood vessel is our aorta. Right, so if you recall, the aorta carries and transports oxygenated blood from the heart to the rest of the body. So this will go up this way, there'll be some branching, right, and it will go to the rest of the body. Okay, so I hope that helps you to see what are the main blood vessels around the heart and that you've drawn the flow of blood through the heart. Now, a question at this point to think about is, do the atria or ventricles have thinner muscular walls? Which chambers have thinner muscular walls? Think about it for a while. Now, it turns out that the atria have thinner muscular walls, right? And that's because they only need to pump blood into the ventricles, and so do not need to generate such a high pressure. So what do I mean? If you look at your diagram again here, right? Remember that blood from the atrium, okay, moves only into the ventricles. So they only need a small amount of pressure to move the blood into the ventricles. However, the ventricles pump blood out of the heart into the lungs and into the rest of the body. So they need to generate a higher pressure, and so the ventricles have a thicker muscular wall. Now, secondly, does the left ventricle or the right ventricle have a thicker muscular wall? What do you think? Now the hint is to think about where the blood is going to go from the left and the right ventricle. So think about it for a while. Now it turns out that it is the left ventricle that has a thicker muscular wall. And that's because the left ventricle needs to generate a higher pressure than the right ventricle. And that's because the left ventricle needs to pump blood around the whole body. Or, if you remember, it pumps blood into the systemic circulation. Okay, so let me bring you back to the diagram and you can see that. So the left ventricle is here. It pumps blood into the aorta, which goes to the rest of the body. So this needs to generate a very much higher pressure because it goes to the rest of the body. This is the right ventricle. It pumps blood into the pulmonary artery, which goes to the lungs, right? So the pressure to the lungs doesn't need to be so high, and so the right ventricle muscular walls do not need to be so thick. Okay, we're going to end off this video by looking at one more structure in the heart. But before going there, what sound does the heart make? Lub dub. And it turns out that this sound that the heart makes is actually due to the closing of valves in the heart. Now we've already seen valves and we saw that valves are found in veins, right? Now in the heart there are also valves. So let's see where they are and how they turned out to make this lub dub sound. Alright, so these structures here are the valves. Now the heart has 4 valves that you need to know in detail. So let's start with this first valve here. This valve lies between the right atrium and the right ventricle. Alright, so this valve is called the tricuspid valve. Tri because it means 3 sides. So something about it has 3 sides. So tricuspid valve on the right side of the heart. On the left side, between the left atrium and the left ventricle, there's another valve here. It is called the bicuspid valve or the mitral valve because it has 2 sides. Okay, bicuspid valve. Now both the tricuspid and the bicuspid valves have a name. They are both called atrioventricular valves because they lie between the atrium and the ventricle. Right? Both of them lie between an atrium and a ventricle. So they're called atrioventricular valves. Alright, so that leaves us with these 2 other valves here. These 2 other valves are called the same thing. They're semilunar valves. Okay, so you can see there's one semilunar valve in the pulmonary artery. Okay, and there's one semilunar valve in the aorta, right, going out of the aorta. Now, what is the function of these valves? Okay, so let's start with the atrioventricular valves. The atrioventricular valve, whether it's the bicuspid or the tricuspid valve, their function is to prevent backflow of blood. So valves are always helping to prevent backflow of blood. In this case, the atrioventricular valves prevent backflow of the blood from the ventricle to the atrium. So remember, blood goes from the atrium to the ventricle, and then the ventricle contracts and blood will go out of the heart, right? Now when the ventricle contracts, there's a risk of some blood actually going back into the atrium. But what happens is that this valve will close and prevent any blood from going back into the atrium. So that's the function of the atrioventricular valve. Same on this side, blood normally moves from the left atrium into the left ventricle, and then the left ventricle will contract, blood will move out of the heart. There's a risk of some blood moving back into the left atrium, but this valve will close and prevent blood from moving back into the left atrium. How about our semilunar valves then? Well, our semilunar valves prevent backflow of blood from the artery to the ventricle. So when the ventricle contracts and blood moves out of the heart, some of this blood might actually flow back later on. So this valve will close and prevent blood from flowing back into the ventricle. Same here on the left side, blood normally is pumped out of the heart, but some could flow back, so this valve will close to prevent backflow. Okay, so that's all for the structure of the heart. Take a bit of time to digest it. I know it's very difficult, so take a bit of time, go through it again, and look forward to our dissection in class. For pure bio students, we're going to take a look at it in more detail when we look at a dissection in class. So I'll see you back next term.